Imagine waking up in the middle of the night and stepping outside, not into darkness, but into a world bathed in a milky, ethereal glow. The sky above isn't dotted with a few stars, but filled with vast, shimmering islands of light. Hundreds of galaxies, each brighter and larger than our full moon. Spirals and ellipses swirl and glow, painting the night with the light of billions of suns. This is life in the heart of a galaxy cluster, where darkness is rare, and the night never truly comes. Instead, a perpetual twilight reigns, galaxies casting soft, ghostly shadows across the land. Our relationship with the night would be transformed, no longer a lonely outpost, but a citizen of a cosmic metropolis. Every myth and story would be shaped by a sky ablaze with the fire of 1 trillion stars. Early astronomers would have known the universe's true scale just by looking up, no telescope required. We would grow up certain that Earth is just one small part of a vast, interconnected cosmic city. So, what exactly are these magnificent structures? A galaxy cluster is precisely what the name suggests, a massive collection of galaxies all bound together by gravity. Think of it not as a loose collection, but as a cosmic city. If our Milky Way is a single house, then a galaxy cluster is a sprawling metropolis containing hundreds or even thousands of such houses. These galaxies are all moving, orbiting a common center of mass, much like planets orbit a star. They are the largest known gravitationally bound objects in the universe. They are ancient, powerful, and filled with a history that stretches back almost to the Big Bang itself. Our own galaxy, the Milky Way, is on the outskirts of one such structure, the Virgo supercluster. But we are in a relatively quiet, suburban street. These cosmic cities are not just composed of the galaxies we can see. The vast majority of a cluster's mass is actually invisible. It's made of two mysterious components. First, there's a superheated gas, an incredibly thin plasma that permeates the entire space between the galaxies. This gas is so hot, millions of degrees Celsius, that it glows brightly in X-ray light, which is invisible to our eyes. Second, and far more mysterious, is dark matter. This is a strange, unseen substance that doesn't emit or reflect any light at all. We know it's there because we can see its immense gravitational pull, holding the entire cluster together and preventing the fast-moving galaxies from flying apart into the void. Living inside this environment would be fundamentally different. The space between galaxies would not be an empty vacuum. It would be filled with that hot, tenuous gas. While it's far too thin to affect our planet directly, it would be a constant source of high-energy radiation. Space travel, even within our own solar system, would become a much more hazardous affair. We would need to build spacecraft with heavy shielding to protect astronauts from this pervasive X-ray glow. The background radiation of the universe wouldn't just be the faint echo of the Big Bang. It would be dominated by the energetic hum of our immediate cosmic neighborhood, a constant reminder of the cluster's power. The galaxies themselves within these clusters are often different from our own. In the dense, central regions, there are fewer beautiful spiral galaxies like the Milky Way. The immense gravity and frequent interactions with other galaxies tend to strip them of their gas and dust, the raw materials needed to form new stars. This process transforms them into huge, old, reddish, elliptical galaxies, filled with ancient stars and little new life. So, while our sky would be full of light, much of it would be the gentle, fading light of old suns. It would be a sky of majestic ancient giants, a celestial museum of the universe's oldest and largest creations. One of the most mind-bending consequences of living in a galaxy cluster would be the constant, visible distortion of space and time itself. Albert Einstein's theory of general relativity tells us that massive objects bend the fabric of space-time around them. Light, which normally travels in a straight line, follows these curves. This phenomenon is called gravitational lensing. In a galaxy cluster, the combined mass of all the galaxies, the hot gas, and the dark matter creates a gravitational field so immense that it acts like a colossal, imperfect lens floating in space. It warps our very view of the universe that lies beyond the cluster. From our vantage point on Earth, we would see this effect everywhere we looked. Distant background galaxies would appear stretched, smeared, and magnified into beautiful, shimmering arcs and rings of light. It would be as if we were looking at the universe through the bottom of a giant cosmic wine glass. Astronomers wouldn't need to search for rare instances of gravitational lensing. It would be a permanent feature of our night sky. We could watch as a distant supernova flickered into existence, its light bent into multiple images, creating a cosmic echo where we see the same event at slightly different times as the light takes different paths around the lens to reach us. This constant warping of light would offer an unparalleled window into the distant universe. The cluster's gravity would act as a natural telescope, magnifying the light from galaxies so far away that we would otherwise never be able to see them. We could study the very first stars and galaxies to form after the Big Bang, their faint, ancient light brought into sharp focus by our cosmic lens. Our understanding of the early universe would be vastly accelerated. We would have a direct, magnified view of cosmic dawn, a privilege born from our unique position within one of the universe's most massive structures. However, this cosmic lens would also obscure our view. While it magnifies things directly behind massive parts of the cluster, it would also distort and block our view of other regions. Large swathes of the sky would be a confusing mess of warped light, making it difficult to map the universe on the largest scales accurately. It would be a trade-off, a spectacularly detailed view of some parts of the distant cosmos, at the cost of a clear, undistorted picture of the whole. Our map of the universe would be both incredibly deep and incredibly skewed, a beautiful but fundamentally warped perspective on reality. Living under a sky crowded with galaxies might seem like the opposite of being alone, and yet it could foster a different, more profound kind of solitude. With so many galaxies nearby, the sheer number of potential worlds and civilizations would be overwhelming. The Fermi paradox, the question of if the universe is full of life, where is everybody, would feel far more immediate and pressing. Looking up at 1,000 galaxies, each with billions of stars and likely trillions of planets, the silence from the cosmos would be deafening. The great silence would not be a whisper from the distant void, but a shout from our next-door neighbors. This proximity would also bring with it an increased sense of peril. Galaxy clusters are dynamic, violent places. Galaxies collide and merge more frequently. A close pass by another galaxy could gravitationally disrupt our entire solar system, flinging Earth out into the cold, dark space between galaxies or sending a deadly shower of comets and asteroids hurtling towards us from the Oort cloud. Furthermore, the supermassive black holes at the centers of these galaxies are often active, spewing out colossal jets of high-energy particles. Living in a cluster would mean living with the constant low-level threat of cosmic catastrophe on a scale we can barely imagine. Ultimately, this cosmic perspective would change us. Our species would have evolved with the knowledge that our sun is just one of trillions in our immediate vicinity. The idea of being special or unique would be harder to maintain. Perhaps this would have made us more humble, more aware of our fragility. Or perhaps it would have spurred us on, encouraging us to reach for the stars with a greater sense of urgency, driven by the knowledge that countless other worlds were, cosmically speaking, just a stone's throw away. Our entire philosophy, our religions, and our scientific ambitions would be shaped by this magnificent, crowded sky. We are, in reality, adrift in a quiet corner of the cosmos. Our view is vast, dark, and mostly empty. This has given us a specific sense of ourselves. But to be a creature of the cluster would be to be a creature of the light. It would be to know, from your very first glance at the sky, that the universe is not an empty void, but a teeming, brilliant, and perhaps terrifyingly grand city of light. And we would be left to wonder if, in all of that light, we were truly, utterly alone, or just one voice in an unimaginable chorus. If you enjoyed this journey through the cosmos, please subscribe to our channel and support future videos. Your support helps us explore the universe together.